Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. The Wittig reaction converts a carbonyl group, C is equal to O, into an alkene, C is equal to CH2, using pH 3P is equal to CH2. Each equivalent of pH 3P is equal to CH2 replaces AC is equal to O or reacts with AC is equal to O to give C is equal to CH2. Moving on to the next step. Fluorine 1, fluorine 9-1, has a ketone at C9. Treatment with pH 3P is equal to CH2 converts the C is equal to O to C is equal to CH2, giving 9-methylene fluorine, the product shown in option A. This is an exocyclic alkene at C9. Moving on to the next step. 9-methylene fluorine has an exocyclic C is equal to CH2, a fulvene type alkene. When treated again with pH 3P is equal to CH2, the Wittig reagent can act as a carbene equivalent in a different sense, but more precisely, pH 3P is equal to CH2 can react with the exocyclic alkene of 9-methylene fluorine via a 2+2, like cycloaddition pathway that is characteristic of phosphorus ylides with electron-rich or strained alkenes. The ylide pH 3P is equal to CH2 reacts with the fulvenic double bond C is equal to CH2 of 9-methylene fluorine through a Wittig type 2+2 cycloaddition to form a 1,2-dioxetane-like intermediate, but for carbon, the reaction of an ylide with an alkene gives a cyclopropane via butane intermediate. The CH2 from pH 3P is equal to CH2 adds across the C is equal to CH2 bond to give a spirocyclopropane product. The C9 is equal to CH2 of methylene fluorine reacts with CH2 from the ylide acting as methylene source to form a spirocyclopropane ring at C9 giving spirocyclopropane 1,9 fluorine, but the product shown in B depicts two fluorine units connected by a cyclopropane ring, a spiro compound of two fluorine units bridged by cyclopropane. And for the final step, the second Wittig reaction on 9-methylene fluorine, pH 3P is equal to CH2 reacts with another molecule of 9-methylene fluorine, acting as a dipolarophile alkene. Actually, the classic result in literature is that treating fluorine 1 twice with pH 3P is equal to CH2 gives the spiro compound 9,9-spirobi fluorine with a cyclopropane, i.e., the two fluorinyl groups are connected through a spirocyclopropane dispyro product, which matches option B. A. 9-methylene fluorine, this is only the first step product, not the final product after two Wittig treatments. C. Exocyclic is equal to CH3. This would require a different ylide, pH 3P is equal to CH3, not pH 3P is equal to CH2. D. Fluorine, simple reduction product, not a Wittig product. Therefore, the correct answer is B. Therefore, the correct answer is option B.